We've seen how to declare new arrays, and we've also seen that the computer automatically fills a new array's cells with some default value. So as an example, each cell in an int array gets the default value 0, and then our program would go through and replace those values with whatever we intended for the cells to actually hold. So as an example, you might create an array of 20 integers, but you only get 5 integers from some interactive input. Then your array has a physical size of 20, but a logical size of 5 cells that are currently being used. From the perspective of the program, the 15 cells that are left all contain just garbage data. So clearly in that case, the program only really should access the first 5 cells if we asked the program to display that array's contents. We don't want to access all 20 cells because 15 of them just contain nonsense information. The key distinction here is between the physical size of the array, how much space it has in total, and the logical size, how much of it holds meaningful information. We solve this problem by tracking the array's logical size using some separate integer variable. You can see here, we immediately, upon instantiating this array, create some variable size, which starts as 0. As we go ahead and introduce meaningful data into the array, then we would increase size as necessary. Now, we saw in a prior lecture how we would generalize a loop so that we could process every element of data in an array of any size. Essentially, we just access every index starting from 0 and going to the length minus 1. That's the array's length minus 1. But when the array is not full, instead of using the array's physical size, its length, we want to use its logical size. So we can see here an example of a chunk of code that's taking some array scores, which is of length 50, and instead of just blindly summing all 50 elements of the array, we would go ahead and only sum the elements up to whatever our logical size was, however many real values were stored in our array. Of course, in that slide, we sort of waved our hands over adding things to the array. And basic idea here is the simplest way to add something to an array is to just add it to the end after the last available item in the array. So the first thing you got to do is check to see whether there's a cell even available, and then you got to remember to increment the logical size. You can see we're doing that here with the size ++. As soon as size is equal to abc.length, we know the array is full, and the if statement is going to stop a range error from happening. Remember, when we instantiate a Java array, we give it a fixed size. We'll learn some other data structures eventually that will allow us to get around this problem, but for now, arrays have to be of a fixed size. And if you want to insert something in the middle of an array, well, then there's some shifting that has to happen, and we'll talk about that in just a second. Now, if I want to remove an element from the array, well, if I'm removing an element from the end, that's pretty easy. All I need to do is decrement the logical size. Remember, the physical size won't change, but the logical size will mean that for our purposes, that value in the end doesn't exist anymore. If we want to remove something from the middle of the array, well, you can probably imagine what that will look like, but we'll treat it formally a little bit later. Let's wrap up by looking at a couple of short programs that use arrays in conjunction with text files. We can see in this first program, essentially what we're saying is I want to create a new array that has 10 slots, and I have the logical size, which currently starts at 0. I'm going to take some user input from the console until the user types in -1. And every time I'm going to store my new number into the appropriate spot in my array, and I'm going to increase the logical size. Finally, what I do is just take those numbers and I output them to a text file. Now, it's important to note here, we're using the logical size as a way to limit the amount of user input. You can see the condition on the while loop, right? While count is less than the array length. That's one of the two ways this program stops taking input. The other, of course, being if the user entered -1. Crucially, our for loop that actually writes to file uses the logical size in its condition. You can see while I is less than count. Again, the critical variable here is count. Another quick example here, we're taking a bunch of information from a text file, just a series of numbers, and we're storing them into an array that's 10 units long. We'll take a look at this while loop. We have two conditions here. We're saying while the count is less than the array length, in other words, while our logical size is still smaller than our physical size, and while there's a next thing to read, well, we want to do all this stuff. Looks like we're getting the next integer from the file, we're storing it in the next open spot in the array, and then we're increasing our logical size. Then we go ahead and write everything to the file, and this is the interesting part. We know if there is anything left in the file to read, that means that we lost some data during our input. And we know that because if we still have something in the file to read, but we're no longer reading, it means we exited this while loop, which means that our logical size eventually exceeded our, or was about to exceed our physical size. So we broke out of there. Two just nifty little examples demonstrating the use of logical size and physical size and text files. As you can imagine, logical, physical size, main ideas of this lecture. We want to be able to know also what happens if you try to access an array cell whose index is greater than or equal to its logical size, but less than its physical size. And see if you can write a program that takes input from the user and fills up a not totally full array. That's it.